First slide, the standard intro slide, air transport is very important. Has anybody never flown in a plane? Has anybody not flown a plane in the past year? One person, two. Oh, a few people have not flown a plane in the past year. Okay, I won't go any lower. The point is that air transport is quite important. It provides it's very important from an economic point of view. If the air transport sector was a country, it would have a GDP roughly about the size of Switzerland or Poland. So it's quite a significant generator of cash, and it's also important from a social point of view, providing lots of jobs, providing the interconnectivity which we need more and more in the modern world. But what's missing from that picture? We'll come back to that question. So Airbus is a global company. It's got all those little blue spots which you can just about see where we have some kind of global presence. It's part of the larger Airbus group, what used to be EADS. Some top-level figures there. Again, I won't go through them. This is the standard presentation. You can all read the slide. But we've got a very big order book, and we've delivered a lot of aircraft already. We've got a lot of aircraft in service, and we've got a lot of customers. And bottom figure there, left-hand side, we employ nearly 60,000 people across the world. And where are those people? Well, this is the core of where Airbus works across the UK, France, Germany and Spain. That superimposition of a larger Europe on top of the world can show you the other places we operate in the world. We actually operate 90% of our business outside of Europe. And before anybody asks any questions, Moscow, just being off the coast of Germany, is to do with how the map has been superimposed. It's not a political statement. I don't want to make any political statement. And what do we make? We make planes. We make aircraft. We make civil airlines, civil airliners. And we provide a comprehensive range of civil aircraft, from the small A320 single-aisle type aircraft, which you might fly in if you were flying from here to a destination in Europe. Or now we've improved the efficiency. You could fly it transcontinentally across the United States. We also provide longer range aircraft like the 330 and our new A350 extra wide body, XWB, and the flagship of the 21st century, the Airbus A380, the double-deck aircraft, which can seat up to 800 passengers in a three-class, well, not in a three-class configuration 800, but standard is 555 in a three-class configuration. So we make planes of various different sizes, from the ones that you're probably familiar with to some of the larger ones as well. I like this slide. It kind of shows the range, our aircraft range, with the how far they can fly against how many people you can fly that distance. And as technology improves, of course, the range improves, and so we can get more people further with a lower environmental impact, hopefully. So you'll see these are corporate slides because the graphics are very good. You'll know when it goes into my slides because the graphics go downhill quite a bit. So the future of aviation, what does the future hold? Oh, I've lost that. My notes on that one. I'll have to ad-lib. Not that I have been already. The future. I saw a video that Airbus produced called "The Future by Airbus," and at the start of the video, it talked about how the future of world transport would be super green, super environmentally friendly, and it would still do the same thing that the aircraft can do. And it conceptualized this idea of having diamond rails stretched across the globe and transport in the form of what look like trains transported by magnetic levitation or something like that across these diamond columns wrapping around the world. But then it said, well, we're not quite there yet. In fact, we're quite some way away from that yet. And so for the foreseeable future, if we want to maintain the standard of living, the interconnectivity, the social, the economic aspects, then what we're going to need to do is look at the way we make aircraft now to take into account a lot more the environmental aspects. So from a sustainability point of view, what is Airbus doing? so anticipating the needs of a changing society. R&T, or R&D&T, so research and development and new technologies. Actually, most of our R&T funding, 90% of it, goes towards technologies and developments which provide a benefit to the environment, 90%. Improving environmental performance to create economic value, and that's an important point, because if you think about Airbus and the product we produce, and our customers and the service they provide, then any improvement in environmental performance, for example, lightweighting, improved aerodynamics, reduced drag, it's going to increase the range of the aircraft, as I said before. It's also going to decrease the fuel burn, which is fantastic environmental reduction, but it's also going to make the airlines more money because they're going to be able to ship more people further, they're going to use less fuel to do it. So environmental performance is, to some extent, hand in hand with economic performance. We're looking at different eco-efficient solutions throughout the product life cycle, so not just looking at we make great planes, how can we make these planes better, but everything about the aircraft. I'll talk more about the life cycle in a minute. And environmental certification. Airbus is ISO 14001 certified. It was the first aerospace company to be ISO 14001 certified across all its operations. And the life cycle approach is part of that. So, talking about the life cycle and how Airbus sees that life cycle. Design, making the product better. Supply chain, so making sure that our suppliers can build in environmental performance the same as we can build in environmental performance into our product. Manufacturing, what we're all here for. Operations, so that's the aircraft in use, so things like air traffic management, and end of life. So we've done a number of research projects looking at how to recycle existing aircraft, mainly aluminium, to future aircraft, mainly carbon fibre. Some examples of what we've done. That's an example of what we've done, a sharklet. It reduces drag, so decreases fuel burn. Looking into alternative fuels, looking into the things I've already talked about, air traffic management. Fuel cells for use on the ground, quite interesting. I'll deviate slightly again, sorry Steve. Using fuel cells for using the aircraft on the ground. I went on a course, and part of the course was to go into a live aircraft that belonged to an airline at an airport down in Bristol. And I went into the cabin. It was a bit cold in the cabin, so we put the heating on. We put all the lights on, put the systems on to look at what was going on in the cabin. And we had our little talk, less than about half an hour. How much fuel did we use in that half hour just to keep it warm and to power the systems up? We used 35 kilograms of fuel just to go in and do this course. So if we can use things like fuel cells and more environmentally efficient, if I can say something like that, technology, then we can eliminate a big wasteful part of or a part of the impact of the aircraft use. Of course, it is completely different to it being in flight. I'll skip very quickly over this one. Somebody mentioned about social aspects. So Airbus does see that sustainability isn't about just hugging trees. It's also about thinking about society. We have the Airbus Foundation, which supports many charities. We have local organisations at each of the plants where we support different local charities. And it's not just about engaging with those people out there in society, this thing called the community. It's also about engaging internally inside Airbus. So we're engaging with our employees as well as engaging with people outside. I've then got a 2-minute video. 2 minute? Is that okay? 2-minute video, if it works. If it doesn't work, it's a 0-minute video, which is our head of production talking about what he thinks. There he is, looking very surprised. I'll rewind a bit if I can. Maybe I can't. Okay.
Environment is at the heart of the values of Airbus, and we are committed to sustainable growth of our company. It is not limited to compliance aspects. It is all about leading the way of environmental improvement for our products, but also for our industrial system. Since 2004, we are addressing the reduction of the environmental footprint of our company. In 2011, created Blue 5, a very dedicated and highly visible initiative to bring together all the initiatives and set very clear targets for 2020 across all our plants. The commitment with Blue 5 are to reduce by 30% the energy consumption and to cut by 2 the emission of CO2 and VOC, volatile organic compounds, and equally reduce by 2 the consumption of water and the production of waste. Also, for all new industrial facilities, the environmental improvements are designed from the very early stage. A recent example is the final assembly line for the A350, where we are providing savings of electric consumptions by 1 million kilowatt hours per year. This is achieved by installing 22,000 square meters of photovoltaic panels, but also using features like enhanced natural light, controlled door opening system, and strengthened insulation. Also, Blue 5 is delivering remarkable achievements, as most of our projects are either ahead of schedule or overachieving the milestone targets on our ambitious road to 2020. We continue to invest in cleaner and more efficient technologies and processes, but also in the awareness and the training of our employees. We truly believe that focusing and investing in eco-efficiency creates huge opportunity and delivers tangible financial results.
Okay, so my name is Peter Ball. Peter Lunt said I could say absolutely anything I wanted. My role here is to take an outsider's view, being an academic who's privileged to be able to go into lots of different companies, to take an outsider's view. And I just wanted to plant a couple of seeds for the end of this presentation. In case you don't ask any questions, we've got 3 questions that we're going to put to you that you either ask them in the room or think about during the meal tonight. Now, some of you are worried that I'm going to tell you about this diagram here. I'm not. You've seen that a couple of times today. Have a think about Airbus and look at the 3 categories that you've got there. I'm not going to do a show of hands of what different people were thinking of, but some of you, let's say for the economic side, might have looked at the economic side for the company or for the region. Some of you for the social side might have looked at what's going on in Broughton in North Wales or other parts around Europe, or some of you might have thought about social mobility as a number of things that Peter's brought up this afternoon through the presentation. And maybe on the environmental side, I'm going to guess that you probably thought about the use phase of the Airbus product. The seed I want to plant with you here is whether we can learn from the immense amount of design effort that goes into designing a product that will minimize its impact on the environment, and think about how we can take some of those techniques and put them into other parts of the design, so the design of the industrial facility. But I promise you I won't explain the 3 sides. Some of you have seen that on posters here and previous conferences. It's just a view of the flows through the ecosphere, the wider environment, and into the technosphere and out again. I think everyone accepts, number 1, the linear flow is bad, and a lot of companies, most companies, are actively moving to that second one, where they're starting to take their wastes and move them around within the technosphere. And into number 3, the cyclic flow. As Steve Hope said about Toyota, then if you're going to buy a new car, you're not going to want materials that have been used in previous cars necessarily in your car. And for regulatory as well as safety reasons, you're going to be pretty worried if Airbus have said they've recycled quite a few bits of their wings and so forth in the airframe. But these are long life, high value products. And so there is a lot of circulation of resources within existing platforms, and that's something that the aerospace industry is very good at. I won't dare to go on to number 4. I'm going to plant a few seeds here on this movement from lean and further on. We've spent 20, 30, 40, many decades, 40 years more, looking at lean and developing lean and improving that type of process. If it's going to take us that long to optimize that side and spread the message throughout of industry, how are we going to move to the other stages? The second seed I wanted to jump to then very quickly was this movement from lean through pollution prevention to eco-efficiency and beyond. Is that just incremental? Are we just improving little bits, and can we make that journey just by making all those little improvements, and therefore we can use our existing, you could say, Western innovation patterns, or do we need to make the step change? So that was one area that we wanted to plant a seed of. How do you make that step change, and can you use existing techniques? So with that, I'm going to very quickly and pass across to Peter, who will present a final slide.
So I wanted to talk about, as I said at the start, how there's top-down approaches, so the corporate type view, the corporate strategy, and the bottom-up approaches, so approaches driven from a factory level. I'll quickly go through these. Vision 2020 was started in 2006, which was our idea for how do we become a company looking out towards a 2020 horizon, including environmental aspects. So how are we going to address some of the key environmental topics? Out of that came our ISO 14001 accreditation. In 2009, the facility management group, that's underneath that, if you can't read it, it says, save energy, make a difference. And that was the awareness campaign launched by our facility management colleagues, and that's what formed the energy multifunctional team. So focusing very much on the specific topic of energy efficiency, getting more towards that factory level, a lot of engagement with the factories, but mainly focused in the facility management perimeter, so improving building lighting, not so much in a real, truly factory perimeter, but still good progress and starting to cascade the objectives towards real achievements. Then Blue 5 came along, which you heard Mario talk about in his video. Blue 5 is the 5 key environmental aspects that we're looking at. Water use, water discharge, water use and water discharge, or water as one, waste, VOCs, volatile organic compounds, energy and CO2. And as part of Vision 2020, we had the reductions that you heard Mario talk about. So that was launched in 2011, starting to look more very much focused on industrial activities. In parallel, there's been some good ideas being generated from the different manufacturing sites. There was a project launched in 2009, 2010. A lot of people in this room will be aware of it. It was called Therm, and it was launched with a number of partners, Airbus, Toyota, De Montfort, Cranfield, and a software provider called IES. And through the Therm project, locally in Broughton, we came up with an initiative called Stretch, which stands for 6 key steps towards improving the energy efficiency of a system, which we shamelessly robbed from Toyota through the collaboration. We took a lot of the other good practice from Toyota, and we developed this system initially at a single facility in the Broughton site, gradually expanding to other parts of the Broughton site. And it got the attention of the people in Blue 5. There's this interesting thing here that's being done at one of the sites. How can we pull that in to this overall corporate strategy? And out of that is what came the Industrial Energy Efficiency Network, which I look after across the sites. And it's kind of balanced between the two. It takes advantage of the local, the idea of having distributed responsibility. So each of the plants is individually responsible for setting their targets, for being accountable to those targets, for carrying out projects. And it's founded on the methodology, a structure. So there's a structure there as well, which helps the individual plants to identify the opportunities and then to go and act on those opportunities. And it's also backed up with some central support in terms of funding, training, resources, and things like that. In terms of what has the network done, some results over the past year. So the first year of implementation was 2013. We carried out a project in one of our sites in Germany looking at lighting control. So we were able to install some motion sensors to react to when people were there and where they went. Very simple project. Compressed air. A few people have mentioned compressed air today. It's you can't really get a picture of a compressed air leak, but I think this is probably one of the ones where you can see the compressed air leak with the marks on the side of the machine there. So a big compressed air leak detection and repair campaign carried out across all the sites actually. Painting, that's a air handling system outside a paint shop. So we carried out a project where we looked at the fan speeds and how the fans were controlled, and we installed some variable speed drives, not shown there, and how we were able to make sure that the paint booth, was operating at appropriate conditions. And a very interesting project, another one in Germany, getting more towards that, thinking of waste as food. That's a CHP, a combined heat and power plant. And you're all probably thinking, those of you who know what a CHP is, you're going to say here that you produced heat and used electricity as a waste product. Well, no, in this case, the heat and the electricity were both the waste products. What we were producing here was exhaust gas. We produced exhaust gas, which was then treated to inert some pressure vessels. Other sites, and this site, had previously bought in expensive nitrogen, or had sucked nitrogen out of the air through very energy intensive processes. But what they did here was, okay, well, when we burn gas in air, we get rid of a lot of the oxygen. So we've got an atmosphere which is suitable for use in the pressure vessels. So we use the exhaust as the primary output and then heat. Okay. I've got to close there? Okay. So you can see the 4 different areas we've been looking at, Kira's been looking at. You can also see the types of activity that we've been doing, and there's a kind of a flow between these which links to the flow of the methodology.